So the claim here was the force of gravity pulls objects down towards the ground. And you already know that a claim is a one-sentence answer to the question you investigated. And it doesn't have a yes or no. Now, try to think of the pieces of evidence that we use to answer this question.
When you throw a ball upwards, it will rise up and then change its direction to fall down. This is evidence I got from the text of force of gravity. My second evidence I got carrying out the investigation, which is about what does down mean. Gravity is the reason that makes objects fall down towards the center of the earth.
Surely there are more pieces of evidence that you thought about while you are reviewing the previous lessons, such as the evidence that we got in the second lesson, which is gravity will always change the object's direction and make it fall towards the ground. Now I'm going to post it. There is also one more evidence that one of our colleagues shared with us. It says, gravity is the reason for falling objects down toward the center of Earth. And as our colleague said, we learned in the investigation the term of falling down. Now we are ready to record a scientific explanation that answers the question. Now record your answer, and when we come back, we will hear a scientific explanation for the Can You Explain question from our colleagues.
Gravity pulls anything with mass towards the center of Earth. No matter what the shape or size of the object is. If any object is thrown up, gravity will change its direction to make this object fall down. If air resistance disappears, all objects will fall to the ground at the same speed.
Your scientific explanations should clarify the effects of gravity on objects. Gravity affects the movement of simple objects, and it also affects the huge objects, such as planets, and make them rotate in a fixed orbit around the sun. You can also mention air resistance and how it reduces the effect of gravity on objects. And as we have seen how skydivers use air resistance so that they cannot collide while they are landing, but what about astronauts? When they explore the planets and land on their surface, what do? Is it possible to design a parachute land on space like skydivers? And this is what we are going to explore in Analyze Like a Scientist, titled Gravity and Mechanical Engineers. In this activity, in STEAM activities are a great chance to share how everything we learned and how are we going to apply it in different fields. In this activity, we are going to know mechanical engineers and who designed the spacecraft, which used their knowledge of gravity and engineering skills to design special parachutes that can land spacecraft on Mars. This is a digital activity, so we are going to check it on the textbook. In the activity, while you are watching the video, keep taking notes on the variables that the engineer considers and test when designing a parachute for different atmosphere. Now let's watch the video together.
After 6 months in deep space, the first astronauts arrive at Mars. They are moving at around 4 miles a second. The next challenge of their attempt to occupy Mars is approaching fast. They have to land safely. Over the past 40 years, Mars has been a lesson in crash landings. Of the 12 unmanned probes that have entered the Martian atmosphere, 5 have crashed and burned.
It's extremely difficult to land things on Mars. You got to think that you have a several-ton spacecraft that's entering the atmosphere at 6 kilometers per second. You have all this energy that you've built up, and you need to mitigate all that kinetic energy. Otherwise, it'll just splatter and crater and make a big hole in the ground.
On Earth, the thick atmosphere will slow down a speeding spacecraft to around 200 miles an hour. But Mars's atmosphere is 100 times thinner. There's only one way to slow down. Use a really big parachute.
So we're walking down this really long sled. That's what we need to be this long to keep all that.
The job of JPL engineers Ian Clark and Mike Meacham is to prevent crash landings on Mars. Any manned spacecraft will weigh close to 40 tons. For those kind of loads, they'll need a radically new type of parachute.
A year ago, we just landed a 1-ton rover on the surface of Mars, the Curiosity rover. And that took all of the technologies that we've developed over the past 4 decades just to do that. And we've now reached the max of that. The parachute we're testing is designed to hold 100,000 pounds of drag. It's something remarkable considering the parachute itself only weighs about 200 pounds. It's a very light structure. It's made from materials like you would build your camping tent out of, nylon predominantly, with a little bit of Kevlar like we build bulletproof vests out of.
It comes through the back of the sled here around that small pulley.
Gotcha.
It goes up through this whole structure, through what we call the pipe guide.
Mike Meacham is the mad scientist of the group. It's his job to figure out how to design and test a parachute that won't rip apart at supersonic speeds.
Parachutes that we're looking at testing now are so large, no wind tunnel that exists right now can hold them. They're just not big enough. So we started looking at every possible way you could test a Mars parachute, all the way of hanging it upside down and putting potatoes inside it. We just thought of everything you could possibly do.
What they came up with includes a Nighthawk military helicopter, 4 Mark 70 missile rocket engines, 4,000 feet of rope, and a 30-person support crew. First, the helicopter lifts the 200-pound parachute, trailing a long rope behind it. At 4,100 feet, the chopper releases the parachute and it inflates. At the bottom of the rope is a piece of hardware called the bullet, which must drop into a large funnel at the end of a rocket-powered sled.
So this structure is 50,000 pounds of steel when you add it up. It's got this enormous steel pulley. That's what's doing the real work, actually. In order to react to all that load, we had to pour 2 million pounds of concrete into the ground. That was a picnic. So these concrete anchors you see around you that this structure is bolted down to, they go down 18 feet into the ground.
Once the bullet drops into the funnel, it triggers the rocket sled to fire, simulating the supersonic speeds the parachute will have to endure on Mars.
We light the outside rockets first. That's our first stage. And that kind of gets this big 100,000-pound sled moving. And once we get up to speed a little bit, we light the inside 2 rockets.
Ian and Mike have run the test once before with a prototype parachute to test the mechanics. The parachute didn't survive, but it didn't need to. That was just a proof of the concept for the system.
Really, the only thing that went wrong during that test was a parachute failure on one of the seams. So as far as the architecture is concerned, it worked perfectly. In some ways that makes us a little nervous for this next test. You know, it's almost going too well.
You set expectations so high already.
Exactly right.
تقدر تتابع كل دروسك على تطبيق مدرستنا بلس. مدرستنا، المستقبل يبدأ الآن.